All right, so let's do this example that we were thinking about in class. F of x is equal to 3x to the third minus 4x to the second minus 5x minus 2. We just have to identify the rational zeros. So the candidates essentially are the factors of this term divided by the factors of that term. So we'd have our plus or minus 1, plus or minus 2, because negative 2 over 1 and 2 over the factor of 1, and then we just have a 1 here. Or we could have plus or minus 2/3 or plus or minus 1/3. Now, if during class we were trying to evaluate all of those, each of those yielded a number that was not 0. Therefore, there were no rational zeros of this function. The intention was, if we were to change our example to f of x is equal to 3x to the third plus 4x squared, so adding a 4 there instead of subtracting the 4x squared, minus 5x minus 2, let's consider we still have those candidates, plus or minus 1, plus or minus 2, plus or minus 2/3, and plus or minus 1/3. Well, I often will test 1 first. 3, 4, negative 5, negative 2. Bring down a 3, I get a 3, I get a 7, 7, and I add, and I get a 2, I get a 0. Boom! Therefore, now I know that x minus 1 times 3x squared plus 7x plus 2 is equivalent to this expression. Well, I can factor this 3x squared plus 7x plus 2, so I have x minus 1 times, and then I might say a 3x here, and I might have a x plus 2. Lo and behold, there we go. So my rational zeros are x equals 1, x equals negative 1/3, and negative 2. Now remember, there was a typo, so we needed that to be our plus 4x. So we'll stop there.